graphs of functions. If we're given functions to graph and we don't necessarily have a way that we know to graph that particular type of function, then we would use a table of values. And so our table of values is going to have an input column, and our outputs are y values, which in this case is f of x. That's the thing you have to remember, is y and f of x are kind of interchangeable. Normally, like if we were plugging this into the calculator or whatever, we would think of this as y equals negative 2x squared plus 5. So y and f of x are kind of equivalent to each other. So I'm just going to start picking some numbers, and so in general I like to pick things close to 0. So I pick things like negative 2, negative 1, 0, 1, and 2. And then we would go ahead and plug those numbers in where x is. And so I'll just show you what the first one looks like, and then we can maybe do the other ones in our head or in our calculator. You just put the negative 2 in where x is, and then work that out. So that's negative 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 plus 5 is negative 3. So that's negative 2, negative 3. And then you keep going, plugging in values until you have a good idea of what the graph looks like. So negative 2, negative 3. If I plug in negative 1, that gives me positive 3. If I plug in 0, that gives me 5. If I plug in 1, that gives me 3. If I plug in 2, that gives me negative 3. So we picked some good numbers here because an x squared means that we have a parabola, which is a u-shaped graph, and we were clearly, without having to find other points, we pretty clearly were able to see the u shape of that graph. So for part B, table of values, I'm going to use the same points, and then I'll just give you an example. If I plug in the first one, what it'll look like, that I plug in negative 2 to both places where I have an x, and then I work it out. So negative 2 cubed is negative 8, and then negative 3 times negative 2 is positive 6. Negative 8 plus 6 gives us negative 2. And then we plug in negative 1 the same way, and we keep working through this. So if I plug in negative 1, I get negative 1 plus 3, which is 2. If I plug in 0 both places, I end up with 0. If I plug in 1, I end up with negative 2. If I plug in 2, I end up with positive 2. Now this is the case where we may want to go ahead and do another point or plug this into our calculator, because we may just not have enough information to be able to figure out exactly what's going on here. Right now it kind of looks like an X, and that's not what it's supposed to look like. If I plug in 3, I get 27 minus 9, which is 18. That's not on our graph, but that tells us that I'm going to be way up here at 3, which means the graph goes up and to the right, and then it's got to go through these points. It's got to come down, up, down. And if you did graph this on the calculator, you'd see that we're pretty close on that graph to how it should look. And C, we've got f of x equals the square root of x minus 2. So we make a table of values. And I can pick -2, 0, 1, and 2 again. But if we realize what's going on with the square root function, that may be kind of an issue. Like if I try to plug in -2, then I get a -4 under here, and that gives me an answer that's not real. I can't take the square root of a negative number and get a real number. So we need to kind of figure out what numbers will work. Like 0 still doesn't work because that gives me a -2. I actually have to go all the way to +2, and then when I plug in +2, I get the square root of 0, which is 0. So go over to 2, 0, and then any number to the right of that now should work. So I can plug in 3, 3 minus 2 is 1, square root of 1 is 1. Now I can plug in 4, but then I'm going to get the square root of 2, and that's gross. So we could try to pick something like 6, because the square root of 6 minus 2 ends up being the square root of 4, which is 2. And then I think any normal numbers, not decimals, will be off of our graph. So a square root function is a curve to the right. It just starts somewhere and then it curves up and to the right typically.